Hello, this is Angela from Neurocraft. In today's video I'm going to show how I build deep reinforcement learning AI capable of playing a game like Pong using C++. So technically speaking, I start by building a really low level artificial neural network library, a single header file that I tried to start on the previous videos, but I decided to show some results using that library in conjunction with some higher abstraction classes and almost a game engine from a book that learns how to beat this game of Pong. Most of the time you won't find anything different from using Python and OpenAI to build things like this. So I doubt you'll find all this stuff built from zero, but I think it's really cool to do that because not only you learn a lot, using this example, as well as you are going to be free to make the game as you wish, not attached to a single framework or some library developed by a third party. So I managed to train this AI during 3 days, I believe. It spends training during 3 days, and as you can see, it's become really good. So how I managed to do that? First, I had to change a little bit the code from the book to adapt from a reinforcement learning perspective of receiving rewards and positive rewards and negative rewards depending on the game state. So basically this game goes from 0 to 21, and each time the pedal deflects the ball, it receives a +1 reward signal, and each time the pedal lets the ball pass, it will receive a score of -1. So just start to explain a little bit the code. So here I had this really low level C++ library that took me almost like 3 years or so to build and get a final result like this. So it starts from printing a tensor to some utility functions to convert an image to column, to fully connected layers, convolutional layers, deconvolutional layers, mean square root layers, and so on. So it's just a single header library. Then I build a higher abstraction neural network class that you just pass a vector containing the number of neurons. So for this example, I just use a fully connected layer. So you pass here the number of neurons on each layer and the activation for the hiding layers and the output layer. And then you have a neural network with high-level abstraction capable of saving also the parameters and loading. Then I build the game. Okay, so this game is based on this excellent book called Game Programming C++ from Sanjay Madhav. I decided just to use the first chapter of this book, where he teaches basic stuff using SDL2 library. So I managed to just change a little bit the code from the first exercise to fit the reinforcement learning environment, where we can pass an action, then the game returns a state, okay, of the current game, like the ball position and the pedal position. And I also made an agent here using double Q learning capable of learning how to play this game. I think I will put all the code in this description of this video. But also about the reinforcement learning part, I like to use this book here from Miguel, Deep Reinforcement Learning, that that gives a lot of practical examples and some advanced using Python. It's not in C++, but you can adapt that. But the thing is that hardly you will find anything related over the internet using like let's put here deep reinforcement learning in Pong. Most of the time, the only thing you can find related to Pong over the internet is these blogs that they replicate this excellent paper on playing Atari games, but using a ready to use out of the box environment like OpenAI and Python. But I think it's really cool when you do things from scratch, because the number of things I learned from this example, I didn't learn it on any course that I did before, and I did some really expensive ones. And also another thing that is magic in my opinion is being capable of being free to model the game like you want. I could just remove, for example, this wall on this right side here, put another pedal and train an agent to play against each other. As you can see here, the game is not perfect because of some problems of frame skip. Sometimes it looks like the pedal deflected the ball, but it passes. But I think it is because the frame skip from the video that I am recording. But other than that, this AI spent almost 3 days learning. Also the results of the learning rewards you can see over here, that started by almost receiving -21 score. That's the lowest case. For the higher score that I managed to get, that is 17 scores in a row. So I adapted the game from this book for if the pedal deflects the ball, it receives a reward sign of +1. But if it let the ball pass, it receives a -1 penalty. Also, I learned a lot about sparse rewards, gradient calculation problems, because sometimes if you use just ReLU layers and ReLU layers in the non-output activation, you will find yourself trapped in exploding gradients. So you have to clip sometimes the values of the gradients to be able to make the neural network to learn. I use a lot of techniques in the book that the book suggested, but I think I managed to make some good progress here. Also, this is the first step for me to create my so dreamed game engine, where I have full control of all components of the games as well as the AI. So I will build. I intend to build a future game engine with a lot of focus on artificial intelligence, and I think this is a really good step through it. Of course, we can make this AI better. I built this first one just with 200 neurons on the intermediate layer, but this is for the first experiment. Also, this AI learns during real time, so we could speed up the training process if we manage how to differentiate the training process from the playing process. Also, I can put another pedal over here and train one AI to beat the other pedal, the other player. That would be cool. And this opens a lot of possibilities that you wouldn't be able to do that if you use our out-of-the-box framework like OpenAI and Keras, because most of the people just know how to use the apps but not how to create something from the scratch. But I think that having something that have full control of the process is a really cool thing too, because it potentializes your learning curve. And I think that's it. I just want to share that with you. I will try to put the code on the description. So that's it for today. Thanks for watching, and until next time.